straight forward. You'll be wanting to be facing the front. So if your back's to me, you might want to grab a board so you can be turned around because we're going to go fairly fast for the first part.
Are we going to do the new?
Uh-huh. So first of all, we are in Chapter 3. We're going to talk about ionic compounds. The test for that is October 26th. It's Friday. So not this coming Friday, not the next Friday because we're on fall break, but the Friday after that. So it's really quick. We don't have very many days in this chapter. All Learn Smart, all homework is due that Thursday night by 11:59. So it's before the test. What did I just say? Okay, everything's due the night before the test by 11:59. Okay, so make sure you're watching that. I will be keeping you up where you need to be. So if you don't get done today in class what I have up on the board, then that becomes homework. So make sure you get it done before you come next time. So the other thing that I've got up here is your hot link to Science Day at the U. If you haven't got registered, please get registered. It is way worth it. Yes, I know it's Harvest Dance. Yes, I know. Yeah, you can sign up for whoever's going with you. Today, I have got up there for you. Whoops, that's not what I wanted to do. I've got the YouTube video from 7th period. I also have the OneDrive link. I'm not getting tired of talking over you, so I'm just going to talk quiet, and then if you guys want to talk loud, you can. Okay, so I've got up here for you both the YouTube video and the OneDrive video link, so you can look at 7th period, what we're going to be doing today if you get behind. Also, I've also got Flipgrid up here. I just want to try it and see how it works. If you have enough time, at the very end of class, I want you to go to here. The code is Chemistry 18, and just show me how to do one of what we're doing at the very end. And that'll make more sense when we get there. If not, that's fine. I'm not going to hold you for it. I'm just trying it out to see how we can use it to help us learn things better in the class. On the 16th, I've got scheduled a lab. It might have to switch with the 22nd. The chemical that I need for the lab is in transit. So if it doesn't get here by the 16th, then we'll do the finish up. We'll flip the 24th or the 22nd and the 16th. Walmart.
So it should be.
Yeah, it's on a slow boat from China.
Oh, you didn't say it was from China. That's why.
No, it's not. I was being very sarcastic. It's just being very slow. Calcium nitrate.
You can give that to Walmart.
Yep.
You have to have a special.
Nope. I'm not telling you how to get it. Anyway, here we go.
You go to Walmart and you click on search and up the right.
Whoops, that's not what I wanted to do. Try again. Slide beginning. We are talking about ionic compounds. So, got a couple of comics up here for you. I find you very attractive. Magnet to iron. That's because iron has a lot of arrows in its orbital notation that are not paired. And because they're not paired, it makes iron magnetic or attracted to things that have opposites. This one right here, you have several different ions. Positive ions that are in the classroom, and on the outside you got negative ions. And it says, perhaps one of you gentlemen would mind telling me just what is outside the window that you all find so attractive. So opposites do attract. Okay, as we go through, come on. I have been having problems with my PowerPoint all day long. Okay, forgive me for not being up there. I'll try and get it running from over here. Might have to go back the old. We had to do this last period. So let's see. It's not even letting me see it anymore. And it tells me it's stopped. Okay, so here is a little video I'd like you to watch, and hopefully it'll be loud enough you can hear it.
This is the story of the alkaline metals who were trying to get rid of electrons. All of them had one in their valence, and they wanted none. This is the story of another family. Group 17 were also known as halogens. 7 electrons were in their valence, and they wanted 8. Till this one day when the metal met the other, the electron transferred to the halogen. Both of them got charged and were attracted. That's the way they became ionic bonds. Ionic bonds. Ionic bonds. That's the way they became ionic bonds. Ionic bonds. Ionic bonds. That's the way they became ionic bonds.
Yeah, a little corny, but it works. Gave you a lot of information there. We'll be going over a lot of it coming up. So going forward, please go forward. It's not going to go forward here. I was hoping after the video it would, but it's being ornery. Okay, so going forward here, hopefully, maybe. Okay, come on. We'll go this way, or we'll not go this way. No, we don't want to do this. Come on. Okay, we're going to go this way. So, your introduction to ionic bonding. Bonding is basically just joining two elements in a stable arrangement. So we're going through your study guide. Elements will gain, lose, or share electrons to reach the electron configuration of a noble gas closest to it. Remember, the noble gases are on the far right column. Okay? Everybody's trying to be like a noble gas. We're going to be talking about covalent ionic bonds coming up. So there will be several slides on all of these that you can go back and look at. So when we look at a bond, we have two types of bonds, ionic or covalent. Ionic is where an electron is moved from one atom to another. Covalent, they share it. Neither one's strong enough to rip off the other. So ionic, we end up with charged ions that are attracted to each other, where covalent, they're just attracted because they're both holding on to the two same electrons. And you actually do have a physical bond going on there. So, to explain that a little bit more, I've got another little video here for you.
Welcome to Dogs Teaching Chemistry. Our first lesson is chemical bonding. Chemical bonds are what holds atoms together. A chemical bond is an attraction between atoms that allows the formation of a chemical substance. The electrons that participate in a chemical bond are called valence electrons. These are electrons that are found in an atom's outermost shell. Let's take a look at the types of chemical bonds that can be formed between atoms. An ionic bond is formed when one of the atoms will lose its electron to the other atom. This results in a positively charged ion, called a cation, and a negatively charged ion, called an anion. Positive and negative attract, and the result is an ionic bond. Covalent chemical bonds involve the sharing of a pair of valence electrons by two atoms. There is also what is called polar covalent bonds. These are covalent bonds in which the sharing of the electron pair is unequal. The result is a bond where the electron pair is displaced toward the more electronegative atom. Thanks for watching, and we'll see you guys next time.
Okay, I know that was a little corny, but it still works. Okay, so we're going to go through this next part pretty fast, so stay with me. Ionic bonds form between a metal and a nonmetal. Remember that the division line is between boron and anomium, and it's a sort of staircase effect going down there. The metals are on the left and lower. The nonmetals are on the right and higher. So if I take two metals, and you can actually get this YouTube video, I haven't put it in yet, but there's a YouTube video of a guy that takes some sodium metal and some chlorine gas and puts it together in a container and then sparks it so that it can get the reaction going, and he actually salts his popcorn that's down below it with fresh salt.
So what do you
Yeah, a little bit risky with the chlorine gas there, yeah.
look up to find
making your fresh salt chemically or something like that. I don't remember what I used to do it. When we do that, we use a metal and a nonmetal. That will form ionic bonds. Now, in that video, it talked about polar covalent bonds. If you look at the periodic table and you take an element from the first column and one from the seventh column, or the second to last column, so not the noble gases but the halogens, those will probably form ionic bonds. They're far apart on the periodic table. They talked about polar covalent. Well, as you get closer and closer on the scale, basically you're sliding your left hand in and getting something closer and closer to the nonmetals. That becomes polar covalent. And as you get two nonmetals together, you actually end up with a covalent bond. So if you just look at the periodic table, you are able to find elements in a compound where they're at and decide right away, oh, that's going to be ionic. Oh, that's going to be polar covalent. Oh, that's going to be covalent. There's not really a dividing line as far as there is, per se, a dividing line where we call ionic above 1.7 in the difference in electronegativity and covalent under 0.5. But it's sort of like a sliding scale. It's really ionic to really covalent, and it sort of slides in between there. Yes?
What if you put two halogens together?
That would be covalent for the most part. I'll be showing you a little bit later, I believe next time, how to actually find out what it would be described as. Okay, so as we look at the outside of a compound, we're able to see, I'm going to try and go back to screen view. Nope, it's not going to let me. We're going back this way. Okay, so we are able to depict things visually a lot of different ways. The first way is just to show the outer shell electrons and show what's happening to them as far as this comes together as a plus and a minus. When it's ionic bonds, this is really not a bond right here. This is just them getting close to each other, sort of like a static electricity on a balloon trying to get on a balloon static to you. Okay? It's because they're oppositely charged that they're attracted. There's really no physical bond there. Okay? So the electron is moved from here to here. That's another way you can look at it. You can also draw it beforehand where it's just the atoms and then it becomes the ions, and the ions are attracted to each other. Just a quick little video or comic here on ionic bonding. I'm a nonmetal, I'm a metal. Together we rock solid, sparks fly, and lots of electricity. We break up, losing all energy and electrons to make ourselves solid. Blah. Boring. Okay, so when we talk about covalent bonds, we're usually talking about two elements that are really close together on the periodic table that are bonding to each other. And you'll notice this time there is a bond. Because they're both holding on to those two electrons, they have a physical bond. So in the video with the dogs, that's where the two dogs were holding on both to those two balls. They both want them. Neither one's strong enough to pull off from the other one. So we call it a covalent bond. These molecules that form covalent bonds are called molecules, where in ionic compounds, we call them ionic compounds instead of molecules. Molecules depicts that there's really not a big positive or negative. So let's go back to talking about ions. Ions are charged species. So we've talked about isotopes. Isotopes have the same number of protons, different number of neutrons. You can have an isotope that is an ion. An ion just is about the electrons. The protons stay the same. The neutrons for that isotope would stay the same, but the ion is how many electrons or it has gained or lost. So when they have lost electrons, we either become positive or negative, gained or lost them. And we make ionic compounds, and they're consistent of a positive and a negative, and what we call a strong electrostatic attraction. So let's look at each of these separately. There are two types of ions. Do I need to turn the light back on? Some of you are nodding. Nodding off, sorry. Thank you, Kyle. All right, so we have a cation, which is when we lose electrons. So a cation is positive. And the way I remember that is cats have paws, and so it must be positive. Haha. Okay. I also lose electrons. If I lose electrons and I become positive, I've lost weight and I become positive. That's also how I think of it. So this cation has more protons than electrons. On the reverse there, if I gain electrons, it's like gaining pounds to a woman. It's a very negative experience, and I become an anion. And you can also think of it as a negative ion looks like onion, and that makes you cry, and that's negative. So however you want to remember it. But an anion is an atom with a negative charge, or more electrons than it does have protons. Okay, so define those how you will. As we look at cations and anions, we want to actually look at the electron configuration that makes them up. Are we okay to move forward? I'm seeing head bobs, so I don't know if you're done writing or if you need a few more seconds. I'm really fast over here when I've got the clicker. I'm not up at the board, so it's being ornery. Okay, going forward, we compare atoms to ions. So if we look at, and this would have come in at different times if I had it up in program. So if we look at this right now, I've taken the sodium ion and I've color-coded it for you according to shell out. So the black is the first shell, the blue is the second shell, and the green is the third shell. You'll notice in the third shell for the sodium ion, there's just one electron. When it loses that one electron, its outer shell with a 2 here, a 6 here, adds to 8 in its outer shell, and the 2s and the 2p. The chlorine atom, it has 7 right now, and you'll notice the outer shell there is in red. If I add 1 to that, then the 2 plus the 6 also makes 8. So I'm trying to get to what we call a noble gas configuration, or an outer octet equal to 8. So, summarizing real quickly, metals like sodium are cations, meaning that they're positive. They're positive because they lose 1, 2, 3, or 4 electrons, and an atom forms a cation. Remember, cats have paws, so it's positive. Nonmetals like chlorine form anions, which are negative. So I'm gaining 1, 2, 3, or 4 electrons to form an anion with a completely filled outer shell of electrons. With that, we need to remember the octet rule. And the octet rule is just this. I want 8 in my outer shell. Whether I have to give up the ones I have to get to the 8 below, or I have to gain to get to the one in front of me. I want to be like a noble gas. All right, for the next part, we're going to just look at the periodic table. We're sort of going to ignore the D and the F, and we're just going to talk about the main groups here. So column 1 and 2, the alkali and the alkaline earth, and boron's family, have specific charges for the most part. Column 1 plus 1, column 2 plus 2, column 3 plus 3, meaning that I'm going to give up electrons to become like the noble gas below it. So on the green, they're going to become cations. In the red area, and you'll notice hydrogen is in both areas because it can be a -1 or a +1. In the red area here, I am gaining electrons to get to the noble gas here on the very end. So this column right here needs to gain 1 to get to a noble gas. Oxygen's column needs to gain 2 to get to a noble gas. And nitrogen's column right here needs to gain 3 to get to a noble gas. Carbon, being in the center, can go either way depending on who it's with. It can gain 4 or lose 4, sort of like the mediator on the periodic table. Okay? So, looking at each of those groups, just rephrasing what's there, the metals actually give off electrons. So, first column gives off 1, becomes a +1. Second one gives off 2, becomes a +2. Third one gives off 3, becomes a +3. This is just another way right here that we can write it. Okay, and we'll be using that later, so that I want you to be familiar with that. When we get an electrochem unit, that's what we'll be using. If we go to the other side, the nonmetal side, this, by the way, should say 7, so I'm going to fix it right now. And save it. Sorry. If I go this way, I'm trying to add to get to 8 because I'm past that midpoint of 4. So if I'm on valence group 5A, which basically on your chart is 15. Okay, 15. I take away 10, that has 5 valence electrons, and I need 3 more to get to 8. 6, I need 2 more. 7, I need 1 more. And it tells you the columns. So nitrogen's family, which is also known as the pictogens, oxygen's family, known as the chalcogens, and fluorine's family, known as the halogens. So moving on. There are some that you just need to know. And yes, I'm posting these. They're already posted for 7th period. So if I'm going too fast, you can go back over them. Okay, so on this, other metal ions that you do need to know. These are some you need to know. Okay, if you don't know them right off the bat, I would write them on my 3x5 card. They're in your notes. With common ions in the human body, you need to be familiar with these ones. Fe plus 2 is present in hemoglobin in the blood. It might be interesting for you to know that iron, when they say iron fortified, when they do your cereal and say iron fortified, all they've done is put iron filings in your cereal. Well, that doesn't sound very healthy, right? The problem is iron 2, which your body uses, quickly degrades within about 12 hours and becomes iron 3. And your body can't use iron 3. So if they tried to put iron plus 2 in your cereal, it would degrade to iron plus 3 before it got to you. So in order for that to work, iron goes into your body. You have stomach acid, hydrochloric acid, that breaks that iron down and makes it iron plus 2 that your body can use for the next 12 hours. So that's why that works. Chlorine is present in gastric juices, the stomach, and other fluids, and helps keep your balance of how much water your body keeps. Na and K are found in all body fluids. This helps us with running our heart, also with keeping our fluids at the measure they need to be. Calcium is found in teeth and bones, and magnesium is needed for nerve transmission and muscle control. So if you've ever had a muscle twitch and it won't go away, you're either low on magnesium or potassium. So those are things that you can do. If you've ever been to the Dirty Dash or ever been to a running thing, they usually at the end have bananas for the runners along with a glass of water. And that's because bananas are high in potassium. As Americans, we usually get too much sodium in our diet, but we don't get enough potassium. Okay, so moving on. Focusing in on those ions again. Sodium, potassium, calcium, and magnesium. Potassium and magnesium are present in high concentrations inside cells. They're used inside cells to make the cells work. Where sodium and calcium are used outside the cells in structure and for calcium and in transmission of moving things and water retention for sodium. The other ions that are important are our Fe plus 2, which is essential for your oxygen transport in your hemoglobin by your red blood cells. And chlorine minus is extremely important. That's your chloride ion. It's present in your red blood cells, in your gastric juices with your hydrochloric acid in your tummy, and other bodily fluids. It also helps in regulating sodium in fluence balance. So when you sweat, if you ever, it's salt you're giving off. It's sodium chloride that you're actually giving off. Okay, so I'm going to do this on the board with you. We're just going to do a real quick review of Lewis dots. And this is all about the columns on the periodic table. Remember, we're ignoring D and F. We're ignoring D and F, and we're just worried about the S and the P. So the first column is sodium's column, and you just put 1 dot there. I don't know how well this is going to work. It's not writing real great. Second one, we put 1 here and 1 here. They like to be opposite because they're both negative and they want to get as far away as possible. In the third group, which is boron's group, we put 3 in a triangle because, again, they don't like each other. They want to be as far away as possible. For the fourth group, that's carbons, we put 1 on each side. It will do what it's called hybridize. It will steal 1 from the S and put it with the P so it can open up all 4 orbits so it can bond with 4 more things so it can have an outer octet. If it didn't do that, it couldn't get those in the S that are paired to bond. And as you get farther down in carbon's column, when you get to tin and lead, a lot of times it doesn't open up that room. It just doesn't have enough energy. Yes? It is 14. So on your periodic table, it's numbered 1 through 18. It's in the P group. So you just take 10 away from the group that's up there. So I'm just going 1, 2, 3, 4, 5, 6. Okay, you just drop the 10. So in the 15th group, we have 5. So we put 2 in the top, 1 on each side. And if you go from this, you can just go 4 and put back on the top. 6. I'm going to do it this way so you can see it. 1, 2, 3, 4, 5, 6. That'll also get you the shape. Oftentimes this one they'll do on test where they'll show it like this, where it has the 2 on the top and 1 here, because they want you to say that shape is linear. It's not. The 2 on the side are like coming out at you like this, and the 1 top and bottom are going back into the plane. So it's more of an angle. Okay, so I like to make sure that even if they show it to me this way on a test, I don't write it that way. I rewrite it this way so I can see how it's actually bonding for the shape. Okay, so that's a little hint. Next one, group 17, you're going to go and put 1 on each side, go back and pair until you get to 7. So you've got 2, 4, 6, 7. On group 18, basically 2 on each side, because we've now reached the noble gases and we're happy. Okay. All right, so on the next page, there are some elements that I would like you to see if you can beat me doing the Lewis dot. I'm going to give you a head start of 1 minute. Remember, you were supposed to have your periodic table out. Ready? Go. I have to erase this. Nope, I'm going to start in a minute after you started. I have to erase this every time. Giving you a bit of head start. I'm going to try and put it back into this. Nope, it still wants to go to the stuck person.
Oh, wait. For 2, is it up and down or is it side to side?
Side to side. I'm going to try and end this and come back into it and see if I can find it while you guys are doing that in my minute. Oh man, you got it done in less than just 60 seconds. Because here goes. I'm glad you beat me because that means you've got it down. By the way, that is not there. There we go. I have to keep looking at that one. Huh. Okay, how many of you eat? I beat both the twins for sure. Okay, so you need to be able to think this in your head. You're not necessarily going to have to write it down every time, but you're going to have to think this in your head. Okay? So let's go ahead and go on to the next page, please. Yes, it works. Okay. We're going to be starting to write here. So I'm going to write that down. But picture in your head what calcium looks like, and then I'm going to just write it for you really quickly. When we think of calcium, is it closer to 0 or is it closer to 8? Closer to 0. So we've got to think about giving these electrons away. When I give those electrons away, that becomes a Ca2+. And it is known as a cation. I can also write that same thing as going calcium will become calcium 2+ by giving away 2 electrons. Okay? If we look at fluorine, fluorine here has 7 around it. Is it closer to 8 or is it closer to 0? It's closer to 8. So I'm going to need to get one to come in, right? because I put 1 in, this is now going to be fluorine. Let me do that in black because it's not showing up real well. Fluorine with a negative 1 charge because it's going to have 8 around it. This is going to be known as an anion because remember anions are negative. And I can write it like this. Fluorine plus an electron gives me fluorine minus. Okay, would you do the last 2? I'm going to wander around and I'll put it up real fast for you. So do the last 2.
All of D block has 2.
Most of it. There's some exceptions to the rule. Two or 1 for the most part. No. No. Keep it colored. Whoa, that was good. Okay, how'd you do? Did you get what I had? Any questions? We okay to go forward? Do you have any questions on what's on the board? How I got it? Okay, if you got what I got, good job. Let me see how our understanding. Thumbs up, I'm getting this. Thumbs down, I'm not. Thumbs sideways, sort of there, but not real there yet.
So the arrows, they have to go where the electron is leaving or
Right. Okay, let's see what we can do next. Now, you've got a picture in your mind. Everybody's trying to get to the noble gases, so I'm taking you step by step through this. We want to be able to look in our mind and be able to say, is this isoelectronic with a noble gas? That means, is it the same as having an outer shell like a noble gas? Okay? So, find oxygen. How many does oxygen need to give away or take in to be like a noble gas? So it needs 2, right? So that would be a -2. This only has a -1. This is not an isoelectronic with a noble gas. Find lithium. It's in the S block. What charge will it be when it is isoelectronic with a noble gas? +1. Good. It will give 1 away. So this is right. This one is isoelectronic with a noble gas. Okay, look at sulfur. Before you look up, decide what charge it would need to be isoelectronic with a noble gas. Okay, tell me all at once. -2. So this is correct, right? Okay, find aluminum. Do you have your periodic table? Go grab another one. I'll grab it for you, honestly. Okay, what's aluminum's charge going to be? Oh, I heard negative and +3. Which one is it? Okay, why do you say plus and not negative? It only has 3 electrons, right, in its outer shell, 3 dots. So because of that, it's going to give them away because it's closer to 0, right? So this one is not right, right? Okay, nitrogen. Find nitrogen. It should have been +3. Okay, so nitrogen. Everybody got an idea where nitrogen is? The P block. How many does it need to give up or take in? Ready? On the count of 3. 1, 2, 3. Gain 3. So that would be a -3, which is right. Okay, find chlorine. I want you to tell me positive or negative in the number. Okay, here we go. Chlorine has a 1, 2, 3. -1 is right. So this one is not isoelectronic. Okay, what is it isoelectronic with? Let me ask that. If chlorine gave off 1 electron, what would it be isoelectronic with? Sulfur, not sodium. Sodium, remembers Na. Okay, Br. Okay, find Br. Is this one isoelectronic with a noble gas? Yes, awesome. Okay, way easy, right? You just need to know which way to move. All right, coming forward. Now we need to be able to do it with just being given the group number. Okay, so look at the group number. What charge would group 2 take? +2. +2, because it'd have to give away 2 to become like a noble gas. So think of, if you're a guy, think of a girl, because if we lose weight, we're happy, and if we gain weight, we're really grouchy. Okay, so if I lose weight, happy, positive. If I'm gaining it, if I have to gain it, ooh. Okay, even if I'm real skinny, they think that. So group 15, gain or lose, positive or negative? Okay, so gain. So what is that? Positive or negative? Negative what? 3. Good. So -3, you'll see it written 3-, and you'll see this written 2+. Okay, group 17. -1. And we also just write a negative, but if you write -1, it's not wrong. Okay, group 13. 3+. Okay, good. Anybody having problems seeing what's going on here? We ignore the D, we ignore the F. There's lots of issues going on in there. We'll deal with them later. We're just taking the easy ones first. All right, so when I do an ionic bond, I'm transferring 1 or more electrons. Transferring. I'm giving it away. We call it a give-take relationship for ionic bonds. Okay, the overall charge is 0. So if we look here, magnesium has 2 electrons sitting in its outer shell. And chlorine wants those 2 electrons right here. When those electrons move, magnesium becomes a cation with a positive charge. And the chlorines become anions with negative charges. I should not have put the S on that one though. And they're electrostatically attached. That doesn't mean they've got a real bond there. It means that they are oppositely attracted. Okay, sort of like that balloon that I staticked. Well, instead of having to write this all the time, we're going to go simplify a little bit, but we're going to look at a couple things first. So if I look at the far one, I have 3 magnesiums and 2 nitrogens. Can you see that? And magnesium has what charge? 2+. So I have 1, 2, 3 magnesiums at 2+. What's the overall charge for magnesium there? 6+. How many nitrogens do I have? And each one has what charge? -2 or -3. So 2 times -3 is -6. So I have a +6 and -6. Overall charge is 0. Can you see how that works? Okay. Same thing when we're doing any of these. I have to add however many chlorines down here for calcium that I need to balance the charge out so it's always 0. All right? So we're going to write it so its overall charge is 0. I've got a calcium and I've got a chlorine here. What's happening is calcium's in the 2nd column, chlorines are in the 7th column. Chlorines want 1, calcium wants to get rid of 2. So I can't just have 1 chlorine, because if I just had 1 chlorine, It'd get rid of one electron, but I'd still have one, and I'm still not in noble gas configuration. So I have to have two chlorines because I have to have somewhere else for that other electron to go. When it moves, I now become a cation, calcium plus 2, and a plus because I've lost that mass and I've shrunk in size. My chlorines have gained electrons and they've got bigger. Okay? So as I'm looking at it, I need one calcium for every 2 chlorine ions. Right? So they're both isoelectronic with a noble gas. Another way to put it, I need to write the cation first. The positive ion always is written first. So even if they mix it up and give it to you backwards, when you write the formula, positive first. So as I write the formula, I write Ca, Cl. I do a subscript to tell me how many. If it's just one, I don't write one. Okay? But if it's more than one, I have to write it. All right? So let's try this again. Just looking at what's going on. So we've got magnesium and oxygen. And this is already written in your thing, so you can write on it if you want to. I put the colored pencils out on purpose so that you can use the colored pencils if you need to. My magnesium is coming off here, and it's going to go in here and here. On the other side here, I'm now saying that I've got a magnesium with a +2 charge and an oxygen with -2 charge, and they're together with a plus sign. There's not a bond there, but they're together because they're oppositely charged and they'll be attracted to each other. Okay? All right, so let's do some that aren't written. Lithium, how many electron dots? 1. So here's lithium with this 1. Oxygen, how many? 6. 1, 2, I'm going to go backwards so that it'll be on this side. Okay, well, I've only got 1 electron that I can move here. That 1 electron is going to go here. That's not going to fill it up. What am I going to need? I'm going to need another lithium. So I'm going to get another lithium in here, put a little dot there, and I'm going to say, okay, this one is going to come in right here. So I'm going to have 2 there. Sorry, I'm a little off. So over here on this side, I'm going to have a lithium that has a positive charge. I'm going to have an oxygen that has 8 around it with a 2 negative charge, and another lithium on this side that has a positive charge. And they'll be attracted to each other. So to write the chemical formula, how many lithiums did I have? That's my positive, right? So I'm going to go Li subscript 2, capital O. Let's do the next one. Calcium. Where's calcium found? Group 2, so it's going to have 2 electrons. And I'm putting it with chlorine. Chlorine has, I didn't write that in the middle, so I'm going to put it here. Chlorine has 1, 2, 3, 4, 5, 6, 7. Okay, well, I can take one of those with 1 chlorine, but I'm going to need what? Another chlorine. So I'm going to put another chlorine in over here. And I'm going to take that 1 electron and move it to that other chlorine. So in this one right here, I'm going to have a Cl that has 8 around it with a minus charge. I'm going to have a calcium with nothing around it but a +2 charge. I'm going to have a Cl with 8 around it with a minus charge. So how am I going to write that formula? Okay, you forgot one rule. Somebody help him. Or you help yourself. Positive first, so rewrite that for me. Good. So just remember positive first. You have really bad news to give somebody, you've got positive news to give them the positive news first, because if you tell them the negative news, are they going to listen to the positive news? No. I don't know. Okay, so let's do aluminum. Aluminum has how many around it? 3. It's in group 3, so we're going to have 3. Okay, and phosphorus, how many around it? 5. It's in group 15, so we're going to have 5. Okay, so we've got 3 to move and 3 need places. So 1, 2, 3, right? So what do I write in the center? Good. 3 negative charge. Good. What am I going to write for the chemical formula? Somebody else? AP? Thank you. ALP. I let you catch that on your own. Good. Next 2, I want you to try on your own. Okay, I walked you through the first 3. Next 2, walk through on your own. I'll put it up in just a minute, but try and do it on your own. Nope, should be BR. Sorry. Make these a BR. Thank you for the catch. No, it's just me and my chlorine world, yes.
You have to write those 2 that are like smoke gases on the outside, positive in the middle.
2 on the outside.
So you have the bromine on the inside and the barium on the inside.
Right.
You have to do like that, right? Like barium and you have to put the barium.
Okay, you tell me. Okay, this is a good question. So do I have to put the barium in the center? What's going to happen if I don't put the barium in the center? Why won't it? Okay, so the one in the center is the positive. I'm trying to neutralize it. Remember, opposites attract? So if I put 2 negatives next to each other, what's going to happen? They're going to repel. So I've got to have that positive in there so it will suck it in. Okay? Good questions. All right, we okay? Were you able to do this? Yes, I was able to do this. Got it. Thumbs up. Nope, I'm really lost and you're going too fast. Thumbs down. Thumbs sideways. I'm sort of there, but I'm not real solid. Going a little fast. Okay. All right. Everybody that wants to copy it down, got it copied down? Good? All right. So we do have groups of elements that hang together and actually have a charge. We call these polyatomic ions, or the gangs of the periodic table. The charge is usually negative. There's only one polyatomic ion that has a positive charge, and that is ammonium. And that's in the green down the bottom. And just like the Hope Squad or some positive group, it's one of the only ones that are positive when you think of gangs. So the rest of them are going to be negative. Either you'll memorize them, and there's a lot of different ways that you can do to memorize them. They've got lots of different places that you can go up and practice till you got them memorized, or you put them on your card, or you use some of them and get them memorized this way. And I'm going to show you a real quick trick. Okay, So here's your periodic table. Everybody look at it. What part of the periodic table is this? The P block. What have I done to it? Well, I've added oxygen, right? Except for oxygen and fluorine. Well, if I'm adding oxygen to everything, I'm not really going to count it. And since fluorine is very ornery, she takes electrons and doesn't share with anybody. She's not going to combine and make a group. Okay? Yeah, she sort of is. Okay, but if you'll notice, here and here I've added 3 oxygens. Iodate's sort of its own thing, and we'll talk about it in a minute. But since I've added 3 oxygen in a sort of upside down L, you see how that works? And then I've got PS, by the way. And you just got to remember phosphorus and sulfur, they're special. They're little special snowflakes. They get it their way. Whatever they want, they get. So they get an extra oxygen, and their column does too. Iodate sort of at the bottom, he sort of slides over there and says, yeah, I'm going to be part of their group because they get more. What I do then is I take this top row and I slide it over. I get rid of oxygen and fluorine and I slide it over. When I slide it over, can you notice something about the charges in the columns? They're the same. So in the first column, away from what would be the noble gas, it's -1, which means it needs to gain 1 electron to be like a noble gas, right? 2 away, -2. 3 away, -3. If you memorize this group, you've got 10 polyatomics. I'm going to show you how to really quickly get another 30. Okay? So this is 8. They're happy. They've eaten. Well, if somebody comes and takes something away from me, I'm like, give it back. I want to fight for it, right? Especially if it's something that's important to me, like my house or my car. I'm going to fight for it. I want it back. Or my kids. So, if I take 1 oxygen away from what's up here on the table, so I get NO2, or I get SO3, or I get ClO2, then I just change the ending of the polyatomic. So it becomes NO2 would be nitrite. SO3 would be sulfite. ClO2 would be chlorite. Okay? The charges stay the same. The charges stay the same. Okay, so then I've got another 10. So there's 20. Well, what happens if, it's really bad. Somebody's taking my house now. They're taking my car. And it's wintertime. I'm out in the cold. I'm going to get hypothermia, right? It's really cold. This is how I remember it in my brain. So if somebody's taken 2 major things away from me, or if they've taken my house and my family, okay, 2 major things from me, I'm going to still fight for them. I still want them back. But I'm going to be awful cold because it's wintertime. So I add hypo in front of the ite. So for instance, ClO up here would become hypochlorite. Still have a -1 charge. Okay? We can also go the other way. What happens if I put 1 more oxygen on? And this is how I remember it in my head. So if it works for you, great. If it doesn't, it's okay. I think of a cat. I'm a dog person. So cats are, to me a little bit useless because they don't go fetch. They don't play games. They just sort of sit on your lap and purr. That's about it. They eat food. Do the other end. Huh? Oh. That's the only thing they're good for, is if you have a barn or you have mice problem, then they're good. Okay, but they purr. That's what you got to remember. Cats purr. And they have everything they need plus more, usually. So I add purr in front of the 8. So if I have ClO4 up here, it becomes perchlorate. If I have PO5, it becomes perphosphate. Okay, and I've got 40 now named. ATE is what's up here on the chart. ITE is 1 less oxygen than what's up here on the chart. Per would be 1 more, and hypo, whatever, ite would be 2 less oxygens. So I've tried to give you a way to remember 40 really fast by just memorizing.
So we should memorize those 10, though, right?
Okay, it's up to you. You can put all 40 of them on your periodic table, or you can remember this little thing and put it on your periodic table, and then put the couple that don't follow with that. It's up to you. Just know that you'll probably be using them. So now we're going to move on to naming. Now, here at Northridge, This is my thing. It's not anywhere else in the whole world, but it's my thing, my way to remind you how to name things. I'm going to call them type 1, type 2, type 3, type 4. The reason why is, in your book right now, it calls them ionic compounds that are named with known charges and ionic compounds that are named with multiple charges. Okay, type 1, type 2. So when you're asking me what type of naming it is, I'll just say it's type 1 where we know the charge, or it's type 2 where it has a lot of different charges. Okay, type 1. Type 1 has to do with column 1. It does not include hydrogen. So lithium down to francium, always +1. Always. Beryllium down to radium, always +2. Doesn't have a different charge. That's just what they'll be. Then you have what's called what I call the slide. And the slide is boron, aluminum, and gallium at +3, zinc at +2, and silver at +1. Okay? If I can remember that, so basically the S block, not including hydrogen, and the slide are type 1. This is how I name them. I take, and I still have to make the charges balance to 0. That's always going to be the case. And I write however many I need of each one as a subscript. Then, to name it, I just name the first element it's with. I name the second element it's with, change the ending to IDE, saying that last one is my negative ion. If it's a polyatomic, I just name it. You already know how to do this. What is the name of this compound? Salt, which is called what? You were going to say it. Sodium chloride. So Na is sodium. I just named the element, right? Cl is chlorine, but you didn't say chlorine. You said chloride. So we changed the ending to IDE. That's it. That's all. Really easy. If it's a polyatomic, a group of elements that hangs together, we just name the polyatomic. We don't change the ending. Okay, so let's practice some. Yep, I can go back for 2 seconds. 1, 1,000. Got it? Okay. All right, so this is just really quickly, because some of them get a little funky. Chlorine, bromine, fluorine, they're pretty easy. You just change it to IDE instead of INE. Please, no flourings. Flour is in the cooking class, not in here. We do fluoride, okay, F-L-U-O, not O-U. Iodine changed to iodide, nitrogen, nitride, oxygen, oxide, phosphorus becomes phosphide, not phosphoride, okay, and sulfur becomes sulfide. Okay, so here's a little comic. I thought it was sort of funny. Get it? Because Na plus becomes NaCl, which is sodium chloride, which is a salt. Ha ha ha. Okay, so let's go ahead and do this. We're going to practice. Now, as you read it, this is sodium chloride, so we already know, we've already worked with this first one, NaCl, right? Going backwards, the negative ion is the Cl minus ion, and the positive ion is the Na plus ion. We just did that on the last page. So let's go to one we haven't done, the next one, Li3PO4. So the first thing I do is I look at the first element. What is it? Lithium. So I know I'm going to name it lithium. I also know lithium is Li. What column is Li in? First one. So it's a +1, right? Now, I needed 3 of them to balance out the PO4. So for the PO4, what's the charge? I needed 3 positives to balance out the PO4. What's the charge on PO4? Good, -3. How'd you get that? Because I needed 3 lithium to balance out that charge. Remember, they have to add to 0. So if I needed 3 plus 1s, I must have a -3, right? Because 3 plus 1s have to balance out a -3. So I'm going to put a 3 negative here. What is PO4 negative 3? Well, look on the back of your periodic table. There's a big polyatomic sheet there. You won't get that on the test, but it's there for you to use right now. So underneath negative 3, I can look really quickly now, and I can find the name of PO4, which is phosphate. Okay, be careful. You have several that end in ite or ate, and when it ends in ite or ate, it's with an oxygen. You know that. Okay? All right, let's go to the next one. Magnesium. What's magnesium? Mg, capital M, lowercase g. What column is it in? It's in column 2, so that means its charge is 2 plus. Sulfide. What is sulfide? Sulfur, good. And how far away from being a noble gas is it, and what charge is it going to take? So it has 6 electrons in its outer shell, so how far away from a noble gas is it going to be? 2, so it's going to be a 2 negative because it needs 2 more. Good. So we got plus 2 and negative 2. Do I need to do anything besides smash them together to get 0? Plus 2 minus 2 already adds to 0, right? So I'm just going to smash them together. Mg, S, done.
So can you explain how the Li and the PO, how you move it all stuff?
Okay, because I found out lithium was plus 1, so I knew this was a plus 1, and I needed 3 of them to add to something, but I knew it had to equal 0. So I knew this was a 3 plus what equals 0? Negative 3. Okay, so that's how I did it. So it's a little bit of algebra, but not much. Not too hard. Okay, so calcium. What charge is calcium going to take? What column's calcium in? It's in the second column, so it's going to be 2 plus. Good. Ooh, NO3. I'm going to have to look on the back of my periodic table and figure out what NO3 is. It's a negative. Is it negative 1, 2, 3? What? Negative 1. What is NO3 called? We'll do that. Nitrate. We'll put it over here so I don't have to rewrite it. Okay, now here's a careful one because, ooh, I've got 2 plus a negative 1. It has to equal 0. I need 2 of these negative 1s, don't I? Yes? To make that statement true? When I have a group, I can't just leave it alone. If I need more than one of a group, think of I've got to pick it up and put it in parentheses. So, calcium, and then I'm going to put the NO3 in parentheses because I need more than one of the group. How many did we say we needed of that group? 2. So I'm going to put the 2 on the outside, saying I need 2 of those NO3 groups. Okay? What was Ca? Calcium. So we just put calcium and then nitrate. Good. Last one.
So how did you get the negative 1 in parentheses?
That's from this charge right here.
Okay.
So that's basically negative 1. If I put a negative, it's a negative 1, right? Okay, so Rb. What charge on Rb? Plus 1. Okay, SO3, looking at the back of the periodic table again. What is it? SO3. Be careful. It's negative 2. What's SO3 called? Sulfite. So I'm going to put that in while I've got it looked up. Okay. So the common factor here, you'll hear me tell you that a lot. The common factor is 2. I want to get both of them to 2. So they'll be plus 2 and a minus 2, right? Well, I already have a minus 2, so I need 2 pluses. So I need 2 RBs. So I'm going to go RB, which is my positive, subscript 2, then I'm going to put the SO3. SO3. Done. Now, I have given you a, what?
That just clicked with the numbers. It all makes sense.
Good.
I had no clue.
It's amazing to me that that works. I want you to do 1 through 10. I'm going to put the score. I'm going to put these up in just a minute, but I want you to do 1 through 10. If you, after 1 through 10 you get this, you got it understood, you know it backwards and forwards, go on to Learn Smart. If you're getting it right now and understand it, great, go on to Learn Smart. Okay? If you're not getting it, take the time, do 1 through 10, make sure you're getting it. If you're still not getting it at 10, use the others to practice more. before you go to Learn Smart. If you do not get these 2 Learn Smarts done today, okay, that's Learn Smart 3.1 to 3.2 and Learn Smart 3.3 to 3.4, they're homework. Make sure you get them done before you come next time. So we're going to be on a really short schedule, and if you put it off, you're going to get behind to the point where you're not going to catch up. So please stay up with me this time. Yes?
So what was the name of that last one we did?
The last one, tell me what the numbers were, or the things. Oh, rubidium sulfide. Ite. Okay, so do these real quick. If you're still struggling, pull me in. I'll help you out. I'm going to put the answers up here after I do one walkthrough. And then please don't look up unless you want to double check really quickly that you got it right, because I want you to try it on your own.
Just enter I if it's not a compound.
Right.
Like switch them, right? So it's allied to that. Okay.
They don't always switch, so you've got to be really careful. So sometimes it's like a 4 and a 2, and you only need 2 of these. So just be careful on that. That is a shortcut, but there is some problems to it. Yep. If you're getting it, though, and you want to skip and go on to Learn Smart, you're more than welcome to do that. But if you're struggling, I really, really, really suggest that you at least do 10. And I will come around and help again after I get the answers up for the first 10. Okay.
You have them all memorized, though, huh?
If you're going to have them by the end of the year. You're going to have them like this. Yes.
So for oxygen, when you're combining it with stuff,
Becomes oxide.
yeah. But would it be like carbon monoxide? What is the
That's type 3. We'll get to it. That's not this chapter, so don't worry about it. Okay? This is nice because they're going to give you a test on just ionics and then a test just on covalence, which is nice. Okay, so if you're listening on the video that I'm doing right now, I am going to close the video down, so if you want to still see what's 1 through 10, make sure you pause it.